Right folks, we've got an interesting memory card lash up using a USB hub. Let's hope it works. It's showing I'm recording. This is of course a Murphy base station, and tomorrow we're going to do a Spirit 40F because I bought one to do up and to show you that of course it's the same innards. So we're going to have to take all the lids off this. The power supply capacitors need changing. Now the customer may well have done this himself. He says in his note that he has, but he needs me to check. Now this is the same customer as the Midland 2001 we saw a couple of days back, where I failed to record the actual repair video but did do the backup subsequent video where I decided it had got inadequate receive audio and PA audio, and so changed some capacitors around the amplifier and brought back full operation, which was a very nice thing to do with that. It's not often you have capacitor problems on the Maxon chassis, and in that case it's clearly been overvolted. Right, so one of the problems with this is the 1000 microfarad capacitor in the power supply, which needs upgrading to either 2200 microfarads or 3300. We had one in from a customer. He'd actually changed it himself to 4700. That's as high as I would take it, or you're going to end up with diode problems with switch on surge. So here we go, the customer has done that, and he's done the 1000 on there, obviously followed one of the videos I've done. But we're going to disconnect that. We're not running it on its own power supply today. What's he put in that? If I put 10 pairs of glasses on, I might see. Yeah, he's put 3300 in, so that's as high as we would normally take it. So good. So what we're going to do is disconnect the radio from the internal power supply, and we're going to run it off our bench power supply. First of all, of course, I've got to go to get the other side of the board, so we'd better take these even more screws out. I'm hoping this is a straightforward retune and test, but I really want to show the Spirit 40F next because of it being identical. Those Spirit 40Fs were also advertised as something with a Japanese sounding name. Not Yupitaro, but something. You lose me. I only saw it advertised once, and it was in something like What's CB for October, November or December 1981. And it was on the front inside cover with a colour advertisement on the, when the Spirit 40F was also known as whatever, or was it ever that? I don't know. This is what we're going to look into. And that's quite clearly says on the board it's Spirit, quite clearly says on the board it's Spirit. So we're going to unsolder the two wires from the power supply, and run the set on the bench power supply. So without the power supply rebuild, these things really hum. And since we've been changing those capacitors, we seem to have eliminated the hum. And all kinds of fixes at the time, like taking the transformer out and putting it in on an angle, which is a fair enough thing. It's got some screening, but if it was screened, it would be even better. But we're eliminating the hum. Now he says the meters don't work on this. The meters don't work on these. These kind of meters were $1.99 a pair at the time. They were as cheap went. It's one of those things. I'll try and strip it down, but we're not going to put any timing into it. But he wants it to light up and look like it works. So the capacitor is changed on here is that one, and it's supposed to be 1000 microfarad. What's he put in? He's put 1000 in. That's absolutely fine. He's 105 degree rated, which is excellent. You still have the polarity protection diode in there as if it was a mobile, but they didn't put the choke in as if it was a mobile, so it's just about populated as if it was the Spirit 40F or the Youppi Watsy thingy, which I can't remember the name of. So these actually work. Now we've been able to iron the power supplies out, these seem to work nicely. Because they were never intended originally to be a mains operated radio, they don't have things like extension speaker socket, not even a headphone socket. Right, so we'll start by connecting our famous crocodile filter, which we usually short out, to the power supply input thingy. So we're running it off the bench power supply as we usually would do. And there we are. Because the on and off switch on these actually switches the mains on and off, which is quite unusual because the Uniden base stations have still got that one to finish waiting for a capacitor. That is at the airport, I've been told. And the other set, we've got to follow the wiring. So unlike those which just switch to DC and the power supply runs all the time, I do like the way that it switches on and off the mains. That is a safer way of doing it. So we are connected. Have we got a suitable microphone? Because it is a funny little dinky thing. Otherwise, I know it's come with a microphone, but I may not have brought it in here. We're on channel 19. We'll go to channel 20. Make sure don't need a mic to have receive on this. We'll make sure that delta tunes in the middle, RF gains to full, squelches at the minimum. I can't plug anything like the SINAD meter in because it'll have to be crocodile clipped onto the speaker. So look carefully at this board because you're going to see it on the Spirit 40F transport board tomorrow, and I'll just give you a flash of that. Cool. And Murphy base. Here we are. We've got a standard replacement mic made up, so we've got comparison. It's a weird pinout which only is used on these. Right, so we're plugged in. We'll put picture in picture on, and I've pressed some wrong button there, haven't I? Right, we seem to be recording. We're still playing it dodgy memory cards, so what you get is going to be what you get. So if we haven't recorded the first section, we're on a Murphy CBH1500, we're connected to our power supply. So we'll switch picture in picture on, and we have got 3 watts output. Now, because I sent the page to the wrong printer, we have it on yellow card, which cost me 15 pence a sheet, and is for printing the hymns out when I'm playing the organ at church, because I have a colour blindness problem and this helps me read the music. So what we're looking at today, 21 to 23rd, Murphy CBH 1500. Right, so keying up, we've got 2.9 watts on channel 420, I can't even speak. 2.9 watts on channel 1, 2.9 watts on channel 40. Well, that's nice and consistent. Low power, 260 milliwatts. And one of the reasons I have this connected to the bench power supply rather than the internal power supply is so I can monitor the current. And it's 847 milliamps. You would expect it to be like 1.1, 1.2 amps. Deviation for what it's worth on this test set, 1212. Oh, I'm on channel 40, no wonder I'm... Wallow. I can't see any audio. Testing 1 2, testing 1 2 1 2 1 2. Wallow. 1 2 1 2. Yeah, there's no audio, is there? I'll just dig his mic out in case the mic's been rewired, the mic socket's been rewired. You get people doing strange things like that. Right, so I've got the correct little mic these came with. And this is what would have come with the Spirit 40F. I don't even know if we get a mic with the Spirit 40F I bought the other day off eBay. But we're going to find out tomorrow, aren't we? And we'll be able to borrow this, won't we? Because it'll still, this set will still be here. Let's see, we've got audio on this mic. Wallow. Put the walkie-talkie back on. 1 2, testing 1 2 1 2. We've got no audio. Right. Well, may as well run with that mic at the moment. It's smaller. So we don't do the VSO on these. Let's have a look at the frequency. Test gear's been on plenty of time. 2779117. I'll tell you what we're going to do. We'll pull that up immediately, and it's a job we can actually tick off the list. Now, where my trimming tool is another matter. It's on the left-hand side instead of the right. So that's one thing we'll do. So our reference crystal is here, and it's done with a coil, an inductor rather than a trimmer capacitor, which is actually a better way to do it. So we're turning the thing down to make the frequency go up. It's a more accurate and stable way of doing it. Well done, Spirit. 2779117 to 2779125. Neither here nor there. The RF meter doesn't work. So that doesn't work. The SWR meter doesn't work. The meter lamp does work, and it's actually the right brightness. People might think that's a bit dim, but it's the right brightness. Don't have public address. What socket it's got is the mic socket, and that works. Switches, we'll go into that later. The speaker works. Let's have a look at what receives like. So we'll dial in the correct frequency into the signal generator, 2779125. I should have set a timer. I think I've got 20 minutes. So what we need to do is to connect our normal jack that goes to the test gear simply to the back of the speaker. Chances are it's the lack of audio will be a capacitor somewhere. So which one is it? There we go. We only need the one wire. It's getting its earth through the aerial connector. Right, let's have a look at the SINAD. I mean, that's fine. 0.65. 0.52. 1.4. Squelch. 300 microvolts. Turn the volume down a bit. And turn the squelch back down. Turn the thing to standby. Park it at 0.3. 0.76. You know, I think this has been serviced in the last probably 5 years, and it's gone wrong. There's no audio on transmit. This isn't as haywire as they usually are. There's no, I can't see any silliness. There could be a cracked core over there. Right, let's go through the transmitter. To do that, I better look at the circuit diagram. I've no idea where the notes are, so we'll have a fresh look. Doesn't hurt to look through. It is the proper diagram for this version, whereas we haven't got the Spirit 40F, I don't think. So we'll use the same one tomorrow on the Spirit 40F and just forget about the power supply. So what have we got? I've got an eye on this memory card as well. Right, if I can actually concentrate on this and find a transmitter, there's the output transistor, MPS 1678 to SC 2036. What a strange bunch. There we go. Well, basically we're starting at transformer 11 and working downwards. 11, 10, 9. So if we can find T11, yeah, it's the one which I think is cracked. So go back to the main meter. And very, very carefully see if it will move. Yes, it will. And it's not quite in the right position. That's now the right position. That was already absolutely spot on. That was absolutely spot on. So we'll now move over to the hexagonal one. Is it the green tool? That wasn't spot on. Right, let's see where we are on the others. Channel 40, 4 watts. Channel 1, 4 and a little bit. Try that again. watts on 20, channel 1 4 watts, channel 40 4 watts. Good. Well, that all brought up the current consumption. You can hear the fan on the power supply. It's a 2.5 amp power supply we have on the benches. When we do business radios, which are in this country, business radios, the maximum license you're going to ever get is 25 watts. But we need to be able to, because we need to tune them up, some of the radios are capable of 45 watts, and so we do have a 12 amp power supply for business radios. But as far as when we do the CBs, we use these 2.5 amp 10 power supplies because they're LED display and I can see them at any angle. The trouble with liquid crystal displays on power supplies is you've got to get the angle right, and the trouble with conventional meters, apart from accuracy, is again looking at them straight on. So that's why we use the 10. What model is it? 7210480. Right, so we now got 4 watts, 4 watts, 4 watts, and with current consumption is now 1.25 amps. Low power has now dropped to 100 milliwatts. I think it's adjustable, so that'll be our next task, to find it. So let's look at presets while we're at it. So VR2 is squelch. VR1 I think it's going to be receive meter. Yeah. So VR1 RX meter, we probably won't see that work. I'll just go through these with you. We'll look at how the audio works on transmit, and that will hopefully so we've got 10 dB attenuator there. That looks to be deviation. VR5. It has a real power meter, unlike modern sets, and it's VR4 by the looks of it. The low power is preset. You get what you get. There we go. So let's jot down what we've got on low power. (120 milliwatts). Back to full power. Right. So that's done transmit. Let's see whether we can tune up the receive, which was working nicely. Start with the detector. We'll go to the oscilloscope, put the S9 equivalent signal 100 microvolts in. I'm fiddling with the delta tune. What I've done now is to use the SINAD meter to give me the best signal. So we'll start with the detector. I've got all these on top of the microphones. Somebody approached me, sent me an email. They said, would I like to demonstrate their products and do an in-video advertisement for them? It's somebody called Rode. They do microphones. So I replied to them. I said, I didn't know you did push-to-talk curly lead microphones for two-way radios. But they haven't got back to me, so I've no idea what they're trying to get me to demonstrate. So if they do push-to-talk microphones, if they're thinking that my production needs different microphones, well, I've got 4 Shure SM58s in front of me. Why would I want to change Shure SM58s to Rode microphones? I don't know. Perhaps someone will tell me how long Rode have been in business and whether they actually do dynamic microphones. I see people with cordless ones which say Rode on them. We're not talking about radio mics. Right. But I'm assuming they wanted me to demonstrate push-to-talk mics because that's what this channel is about. Perhaps they've not really watched it. I digress. Well, where are we with this? There's our detector. Looks like T8. We can work back from there. So it's 8 is the detector, and then 7, 6, 5, 4, 3, 2, 1 are your receive ones. 1's the front end, 7's the IF, and so on. So transformer 8, all we've got to do is find transformer 8. And that's that one. Let's put some volume on, show that, oscilloscope. Absolutely spot on as it was. Turn the volume down a bit, go to the SINAD meter. I will just see whether twiddling the receive preset actually does have any meter deflection. Especially if I knew which preset 1 is. That's 3, that's not. That's 2. That's going to be deviation. Well, I'm getting nothing on the. I'm just wondering if we connect another meter to the meter. Do you know what I'm getting at? So we can see the S meter, because it's useful when we're tuning the IF. So I'm going to start at the other end. We'll go to the SINAD meter. I'll go to the other end. We'll start with the front end with transformer 1. So I now need to show the SINAD meter. It's about 4 dB. Transformer 1 is there. Okay, so we're now on a different memory card. So what you didn't see, this is a AliExpress cheap memory card instead of a branded one. Let's see, we got as far before it bombed out. We got as far as we'd tuned that in the receiver. I then did these two, and before I moved on to the IF, what we didn't record, I said I want to use, because the meter doesn't work on the front, I want to see what the meter has to say. So we're going to use this more expensive meter. I normally use the cheap little one on purpose to prove a point. We do have a Keithley meter on one of the benches, but it wouldn't be convenient to show on here, so we'll use this one. What I'm wanting to see is the meter. Which wire is that? Oh, there we go. Now this has a bar graph on it, and that's what I'm wanting to see. I'm going to have to tilt that so I can actually see it. So I want to see this bar graph move on the meter, as well as me looking at the SINAD meter. See, if we drop the signal, we can see that moving, which is what I want. So there we go. That's probably as low as we dare. Proves the drive circuit works to the meter that doesn't. So I'm going to tune these using this, but also looking at the SINAD meter. Less. So I want the centre of that range, which is there. Same with this one. No, we're not going to see that on there, so we'll be back to using the oscilloscope. But at least we were able to tune that. We might just be able to see this other one. Or not. Well, at least we got one tune, which is what I wanted to do. Just check this one. And we'll just check this one. Seems to be about there. Right, what else does that leave us with? What are these two? T6 and T7. Yeah, they're part of the IF. If I bring that meter back, I might see them on that again. I keep discarding my notes on sets like this. I thought, well, I'm never going to see another one. So put that on the back of the meter again. I'll drop the signal. glare on there, haven't we? That's better. I've got 3 dots on my bar graph. Less. Definitely the centre. And I'll just do a centralisation twiddle looking at the SINAD meter in a moment. And I think that is going to be the amount of 10.695 going into the receive IF. See if I'm right. I can't see that, but we'll verify that. Right, we'll come away from that meter again, and I'll just make sure that they're absolutely as central can be using the SINAD meter. There we go. I'll just verify which coil that is. Take some of this wiring away temporarily so I can see the T12. And there we have T12. And that's what it does. Yes, it's the amount of 10.695 going in. So we've got that centralised. Right, well that is as tuned as we're going to get this. Let's get a new SINAD reading. So there's our 12 dB mark. And we've now got 0.46. So it has come down. .4 and 0.85. Well, that'll receive another 100 yards, won't it? Yes, Mr. Tango, probably. Squelch. So, let's go over to the attenuator. Memory card still memorying. We want camera 6, and I'll just move it so you can see the left hand knob. We're on 1, I want it at 100. 3, 10, 1, 30, 100. Squelch isn't open. I want the squelch to be open. So the squelch preset is 2. It's that one. Okay, well it doesn't open as 100 microvolts. So that's our minimum squelch position. Set threshold on the radio. Signal generator back on. 0.5. So that's got better sensitivity, but we've not gained at the other end. It's quite a big signal. It's 10 millivolts. We've got to now come to why we've got no transmitted audio. Back to the main meter. We're on deviation, and I know it may not be accurate on this test set, but at least we will know when it's working. And then we'll move over to the other one. So get my walkie-talkie back on the job. Testing 1 2 1 2. Right, so turn the volume down on the radio. Here's a quick tutorial. So I've blown up this circuit diagram, no, not with explosives. This is the bit that's relevant. So this 4558 chip is used as a speech processor. So that is IC what? Why can't IC2. So it's an 8-pin jobby. So we've got an 8-pin chip down there. And what I don't want to do is just fiddle with the deviation willy-nilly, because there's a reason this isn't working. Now we can have, these chips can fail. That's what we're talking about there. Let's switch this to low power, so while I'm in transmit it's not getting hot and bothered. So what I'm thinking about here, I'm just going to put my finger on a screwdriver, just to introduce some hum. So here's where it goes into the, let's move that. So the mic goes in, this wire here, it goes via that capacitor 69 into pin 5. So there's our mic. So what it then does is come out of the, it gets amplified in there, it comes out of pin 7, goes through some speech processing larky, and it goes back into the same chip for amplification a second time at pin 3. And then it comes out, there's our deviation, it passes through that capacitor. So you notice that at pin 7 it comes through this capacitor here, 1 microfarad, goes through all this malarkey, and then it goes through this capacitor, passes through, it's like that record, isn't it? The music goes round and round, whoa, and it comes out here, and it goes into the transmitter's varactor diode. Now you've got a capacitor there, which if it was leaky would drag the audio to ground. If that was leaky, it wouldn't pass properly. If that was leaky, it wouldn't pass properly. If that was leaky, you'd probably get robbed of power. There's a possibility to some extent, but I don't think so. So I'm going to put my big fat finger on pin 1 and see where we get a buzz on our walkie-talkie, because that's the output before it goes into the deviation control. If we get a big fat buzz from our big fat finger, then that capacitor looks like it's going to be okay. And then we can put my big fat finger on 7 and 3 to see where we're losing the signal. Could have a duff chip, or it could be 3 capacitors. There we go. I don't think it's going to be anything else. So pin 1 is the one with the mark. So we've keyed up. Let's turn the volume right up. And if I put my finger on there, tell you what, there's not a lot happening there, is there? Just to prove it, 3, hardly anything, 7, so our mic input at 7. So let's just poke around at this variable resistor, which is the deviation control. There's hardly anything there. That should be absolutely wall-to-wall and treetop toggle, buddy. So, I'm now thinking that we have... Oh no, that capacitor is not... I'm looking at the wrong line. We could have a faulty varactor diode. Which is going to be this one. So coming out of there, going through that small value capacitor, we're going to there. So if I can find the far side of resistor 76 or the varactor diode VD1, poke my big fat finger on there, could have a faulty diode, or it could be being dragged down. It still could be being dragged down by that, but there you are. Let's have a look. I've already forgotten what I've told you, and I'm looking for VD1 or resistor 76. VD1 or resistor 76. Let's guess it's going to be all in this wax. That's going to be fun to find, isn't it? So you've got no layout for these sets, so we've just got to try and find it. Resistor 75, resistor 76, pin 14. Like a needle in a haystack. So you know why this set's been discarded, don't we? That looks like a varactor diode. VD2. Of course I want VD1. Well, that was typical, wasn't it? Capacitor 86. Is that anywhere? I'll have a poke round on this and come back to you. Right, so I uncovered the two resistors I was looking for, 65 and 66, was it? 75 and 76, and I got the buzzing I would expect. I've taken the preset out as twofold because it could be faulty, and secondly, so I've taken that out, it could easily be faulty. I'm going to put a new one in, but I'm going to do some tests with it out. So I'll switch. I don't need this connected. We've done the receiver. So switch the radio back on. Turn the volume down. You can see where I've taken that out. So into transmit. And where's my pokey screwdriver? That's it. Absolutely loads of deviation there. That will turn the radio back off. Put this new one, these are 1K, 1000 ohms. The only place we seem to be able to get these type of presets, which are called skeleton presets, is from Rapid Electronics. Well, they're only a trade supplier anyway. I remember when they were 9p each. What are they now? 45p plus VAT or something? There we go. I'm going to hold that in and kind of... Oh, where's the solder gone? I can see me having to go to the chippy bench for some solder. Let's see if we can stop it falling out. we'll be back. Right, we've raided Mr. Chippy's solder. Can't really see any dry joints, but we'll just look at the same time. There we go. So it's either going to be exactly the same or what? Let's put this power back on. Press transmit. Testing 1 2. And it's exactly the same. Now I'm not going to bother. What we're going to do, what I'm not going to do is bother fiddling with the preset. We haven't got that much there, so I think we've got a capacitor further back here robbing it. See, we're in the central position there. So back to the original situation. What would drag that down? Well, I mean, to some extent, yes, that would drag it down. But I think it's we're taking the preset out. We've proved that from the wiper downwards, we're getting a lot of audio. So putting the resistor back in, it's being robbed. So let's go for capacitor 77, 4.7 microfarads. All I've got to do is find it. It's capacitor 77, just there. So whip that out and see where it is. Okay, so behind the scenes, I changed the capacitor here in case it was dragging it down, because it's being dragged down by something is dragging it down, because remember we took the preset out and I'd got a full amount of audio, so much so it was over deviating just with my finger. Putting that capacitor back in, no difference. So I've moved backwards. I thought we'll change that capacitor just in case. I've changed that capacitor, no difference. I've now changed the chip. So I've taken the 4558 speech processor chip out, and these, I've got about 6 of these left from the 1990s, and this is not a Billy No Mates, pals. This is a JRC chip. Probably cost as much as the radio. Anyway, I think it was for ICOM business radio originally when we bought those in. Right. So here's the moment of truth. Keying it up.
Oh, 1 2 1 2.
Right. That's our deviation back, folks. So it was actually the chip. So we've changed the preset. We've changed the 4.7 microfarad capacitor there. We've changed the 1 microfarad capacitor there, and these are all part of the diagnosis. So we're looking at 45 pence for one of those, 16 pence each for the capacitors. Don't know what those chips are, I'll have to look it up. So we're done. We'll put it into the deviation meter behind. I'll just do it on this deviation meter first. We'll start at halfway position. Voila. And to my Marconi test set, that would be a peak at 2.5. So we'll go over to the test set behind me and let's see where the deviation is. Oh, it's absolutely spot on. So the Marconi test set isn't lying today. So we've proved we've got meter voltage up to the meter, but the meter is faulty. But that is part of the course on these. see whether we can look into that. But first of all, what we're going to do is we're going to check the mains power supply. Oh, I'll tell you what, we'll check the factory original mic. How about that? Because once again we're on our standard replacement. It'd be funny if there was no audio on this mic, wouldn't it? Put the handheld back on. Testing 1 2, testing 1 2 3 4 5. Sounds awful. Wallow. Right. Anyway, I'm not here to worry about people's microphones. They know how to get another one. So there you go. It was the IC that was actually the problem. And this same IC is used in 78134s. Sometimes, you know, like 1 in 300 sets, you find that IC's gone down. So there you go. But it's now got a JRC one in. Japan Radio Corporation. Alright, let's go back to I was going to say the clipboard, but the clipboard isn't here today. So it's 2.2 to 2.5, we've done that. It's 4.7 microfarad, 1 microfarad, 4558 IC, and a 1K preset. There we go. That wasn't easy to find. So next, we'll disconnect this from our power supply. So, I'm sure all this is correct. This gentleman used to do computers to component level, so he's changed that to 3300, which is fine. And you'll notice a general type of 3300. It's not the CAN type used in the base stations like you got. I mean, that's a 2200, but the snap-in type, which are intended for power supplies, you know, like you'd get in the Uniden and the Cybernet bases. This is an ordinary type. It's not got some mega ripple rating, so they are easy to come by. So we'll check he's obviously got it in the right way round. So he's changed 1000 for 3000. He's got 100. I think they're all 100, the others. 100, 100. Yeah. Look at the circuit. So that's the 1000, which is now 3300. 100, 100, and the third one. 1, 2. Well, I can't see. Oh, I bet it's that one off the page. Anyway, they are correct. So what we're going to do is power it upside down and check we've got the mains lead. Again, I've no reason to expect any wiring problems in the plug. He's got a 3 amp fuse in there, which is correct. Nicely done. Shrouded plug, not like the old ones which are now banned. Right, we'll plug it in. Switch it on when I can find the on and off switch. And we should now have, where's my normal meter? So remember, it's disconnected. We should now have positive, negative across here. We've got .4, So we'll turn that to 13.8, and this is offload, of course. This is going to show a minus figure if it's on. I might not. I don't. Which way around am I? Ground to the top. Doesn't matter what way I do this. Other way. $13.81. Right, we'll turn that off. And connect the radio back up to its internal power supply. I can see we're still recording on the Billy No Mates memory card. I'll do these one at a time, otherwise they're going to fall out, aren't they? Yes, Mr. Tango, they're going to fall out, because they will do. Got to sneak back Mr. Chippy's reel of solder before he notices it's gone. I'll be going over the board with isopropyl alcohol as well, tidy it where soldering's been taking place. Right, I'm going to switch it back on. It's still upside down. It's on its power supply. It's 13.8. When we key it up, it'll probably drop to about 13.2. Well, folks, it doesn't. Good. Right. I need that trimmer back. There we go. So we're back to 4 watts. So we'll do the isopropyl and we'll do the lids. Listen to it now, it's on its power supply into my walkie-talkie.
Testing 1 2. 1 2 1 2.
Excellent. Right, I'll get it unplugged. And there you go. A Murphy. Which had a nasty fault. I'll pause the video while I clean the back of the board. Right, so that's done the isopropyl alcohol on the board. Cleaned up all around there. So we can put the lids back on. Okay, which way round does this go? Well, it's going to be the big feet to the front. So the thing to do for people who don't always realise is to put all the screws in loosely so that it all lines itself up. If you start putting them in tightly, it won't. Right, so we'll now start tightening them. It'll be nice and square. It's got all the right screws, so it's come from a good home. Put a couple of screws in on the case on video, and then we'll finish the video with the usual flick round the channels, and we'll either hear swearing from Nottingham or we'll hear nothing. It's coming up to 2 o'clock in the afternoon. It's Tuesday. So again, we'll put these in loosely. These were distributed solely by Great Universal Mail Order Catalogue Group. That, of course, was quite a few catalogues like John Moore's as well. Great Universal, John Moore's, oh, it'll come to me how many different ones. And they were £99.99. Very cheap. And then they got cleared at about £69. I remember buying our sample one from Comet for £69.99. I don't think they ever went cheaper than that. And I thought, oh, I know what this is. It's a Spirit 40F in a big box. I'm still not being very tight with the screws. I'll put the back two in at my leisure. Make sure they're snug, not tight. So we'll do our on the air test for this evening. Change the test equipment into the aerial socket to the aerial. And extract the mains lead. I'll kind of hold it so that it's not back on its... Yeah, I mean, it looks hardly lit, the display, but it's how it's supposed to be. Right, 19. Make sure that RF gain's at full. 1 Anna Roger. There we are. Nothing on. Good. That's what love's so wonderful about living in the middle of nowhere. That just about reaches. And we're going to do on the air test with the standard replacement mic, because I thought that sounded awful, that original one. So the next question is, where did I put it? I put it there. Let's give that 1-9er Roger another Roger. 1-9er Roger. Nope, there we go. Right, well, thanks for watching Murphy CBH1500 with no transmitted audio. And that's a radio from about 1983.